Here the problem is a plank of mass m1 with a bar of mass m2 placed on it lies on a smooth horizontal plane. A horizontal force growing with time t as F is equal to At. A is constant, is applied to the bar. Find how the accelerations of the plank A1 and of the bar A2 depend on T if the coefficient of friction between the plank and the bar is equal to mu. Draw the approximate plots of these dependencies. In this figure, a bar of mass m2 is placed over a plank of mass m1. Coefficient of friction between bar and plank is mu. Lower surface is perfectly smooth. A time dependent force F is equal to At is acting on this bar as shown in this diagram. As the given force F is equal to At is time dependent, and from this equation it is also clear that as T increases, F also increases. At T is equal to 0, the force F is 0. In this case, there will be no force of friction between bar and plank. No force of friction between bar and plank. But after T is equal to 0, as T increases, a force of friction between M2 and M1 comes into play. Direction of force of friction. If we assume the contact surface between bar and plank perfectly smooth, we find that M2 moves in direction of F relative to M1. So the direction of force of friction Fr on block M2 will be opposite to force F. So on this block, the direction of force of friction is this. Suppose it is Fr. Now by action-reaction law, an equal and opposite force Fr will also act on plank of mass M1 in the direction of applied force F. As we know that static friction is self-adjusting in nature, so as F increases, Fr also increases and equal to F unless it reaches its limiting value. Suppose at time t0, Fr reaches to its limiting value. In this case, applied force F will be equal to At0. It is also equal to limiting friction. After time t0, a relative motion starts between M1 and M2. Now we divide the problem into two parts. In part first, t is less than t0. In this case, there will be no relative motion. And in second part, t is greater than t0. Here a relative motion takes place. relative motion starts. Case first, t is less than t naught. In this case, there will be no relative motion, so both bodies can be considered in a single system. And suppose the accelerations of each body is a. So this acceleration will be given by a is equal to net force on the system, it is F, and total mass of the system, it is m1 plus m2. Now case second, when t is greater than t0, in this case there will be a relative motion between m1 and m2. Suppose the acceleration of Planck m1 is a1 and that of bar m2 is a2. Now from this FBD of bar m2 we can write normal reaction N is equal to m2g, force of friction Fr is equal to mu n, it will be equal to mu m2g, and equation of motion of this bar is F minus this force Fr is equal to m2 a2. From here a2 is equal to F minus Fr upon m2. It will be equal to F minus mu m2g upon m2 equal to F upon m2 minus mu g. Now from this FBD of Planck we have Fr is equal to m1 a1. It means a1 is equal to Fr upon m1. Here Fr is mu m2g and m1. Now we calculate time t naught. Up to t is less than t naught, we know that there will be no relative motion between m1 and m2. So if a21 is relative acceleration of m2 with respect to m1, then a21 will be equal to 0 in this case. It means a2 minus a1 will be equal to 0. It means a2 minus a1 is equal to 0. Now substituting the value of a2 and a1 in this equation, we get F upon m2 minus mu g. It is the value of a2 and the value of a1 is this, equal to 0. From here we get F upon m2 is equal to mu g plus mu m2g upon m1. This implies F upon m2 is equal to mu g, taking common mu g from both these steps, we get mu g 1 plus m2 upon m1. F will be equal to mu G M2 M1 plus M2 upon M1, as F is equal to 80 at time t naught. So 80 naught will be equal to mu G M2 upon M1 M1 plus M2. It means T naught is equal to mu G M2 upon A M1 into M1 plus M2. The acceleration time graph of Planck and bar system is shown in this diagram. Up to time t naught, the accelerations of both bar and Planck remain same, and after time t naught, acceleration a1 is given here, is constant, and a2 is time dependent and it is increasing from this equation.